Have you ever wondered why your ears pop when you ascend rapidly in an elevator or plane? Or why deep-sea divers need to be so careful when returning to the surface? This phenomenon is all down to fluid pressure. Picture a swimming pool. When you dive in, you can feel the water pushing against your body from all sides. This is fluid pressure. It is the force exerted per unit area by a fluid, acting in all directions. The deeper you go, the greater the pressure. Why? Because the weight of the water above is greater. This is where our first concept, hydrostatic pressure, comes into play. Hydrostatic pressure is the pressure within a static fluid, meaning it is not moving or under any external forces besides gravity. It is the pressure exerted by the weight of the fluid itself. The deeper you go, the more fluid there is above you, and the greater the pressure. This relationship is expressed mathematically by the formula pressure equals density times gravity times height. But fluid pressure is not the end of the story. When we talk about pressure, we have to consider two more types: absolute pressure and gauge pressure. Absolute pressure is the total pressure exerted by a fluid. This includes the hydrostatic pressure, plus the pressure due to the atmosphere above it. It's the most fundamental measure of pressure, as it accounts for all the forces acting on the fluid. On the other hand, gauge pressure is the difference between the absolute pressure and the atmospheric pressure. It's often used to measure the pressure of gases or liquids that are not directly in contact with the atmosphere. So in essence, absolute pressure equals gauge pressure plus atmospheric pressure. These concepts may seem abstract, but they are incredibly important in a wide range of applications. Understanding fluid pressure can help us grasp everything from why your ears pop in an airplane to how hydraulic systems function, and why deep-sea divers need to decompress slowly when returning to the surface. To summarize, we've covered the concepts of fluid pressure, hydrostatic pressure, absolute pressure, and gauge pressure. Each of these concepts is key to understanding the behavior of fluids in a variety of real-world applications. So, next time you're in an elevator or diving into a swimming pool, remember, it's all about pressure.